Scientists spy on superbugs to see how they outsmart our antibiotics. Scientists have discovered yet another way that single-celled organisms have outsmarted us. The tiny bacteria that live inside our guts have an ingenious way of withstanding the onslaught of antibiotics we throw at them, according to a report published Thursday in the journal Science. The two-part system, microbes 1, humans 0. I.M. Lest Erlen and his colleagues already knew that superbugs could repel even our most modern medicines. What they didn't know was these. For most of human history, bacteria have had their way with us. Though some of them are helpful. When scientists first developed antibiotics in the early 1900s, humans enjoyed the upper hand for a while. Some of the drugs, it took just a few decades for the first drug-resistant strains to appear. Since then, doctors responded by prescribing another antibiotic drug, and another. Then two drugs so scientists are racing to understand superbugs' tactics. Among the most urgent, bacteria know better than to wait around for a random mutation in their DNA that will protect them from antibiotics. Those mutations, luckily for bacteria, they have plasmids at their disposal. These are circulars. Imagine having an anti-cancer gene and being able to pass out copies of it to everybody you bump into at the grocery store. Like I said, Lest Erlen's team wanted to visualize exactly how the exchange worked. They put a regular logic suggested the bacteria cells lacking the ability to resist the drug would die. Instead, less than 2 hours later, the plasmid produced a protein called teta-resistance factor, which makes bacteria impervious to tetracycline. That was shockingly. The next question was this: how could bacteria get away with producing drug resistance proteins right there in the presence of a protein-inhibiting drug? As the hosts on QVC might say, one can never have too many accessories. That's especially true for something called the AcrAV-Tol-C multi-drug efflux pump, which sits on the cell's outer membrane and ejects various toxic antibiotics that have invaded the cell's interior. Despite the pump's fancy-sounding name, it's not sufficient to keep the cell thriving amid a surge of antibiotics. But it buys vital. In the team's experiments, the pump kept tetracycline levels low enough to give the cell a chance to translate the resistance gene into a version of the teta protein that was immune to the antibiotic. Then the teta protein took the reins in sustaining the newly drug-resistant cell, which went on to grow and multiply. Thanks. Rudimentary microbiology discoveries like this one might seem far removed from the front lines of the war on superbugs. But military Lest Erlen's team has revealed For one, the findings hint at the collateral damage from our century-old approach to fighting bacterial infections in humans. Overusing drug. Now that scientists understand the mechanics of plasmid transfers, they can try to create new treatments that attack the multi-drug efflux pumps that allow resistance to spread. Bacteria. For now, scientists remain locked in a race that could mean life or death for all organisms involved. The United Nations warns that, without action, drug-resistant infections could kill 10 million people annually by 2050. That's a public health. After all, bacteria have a few billion years of guerrilla warfare under their belts.
Raindrop, drop top smoking, no cooking the hot pot. Fucking on your bitch, yeah, that. Looking up, open the park pot.